Good morning, Moin. Sorry to hear about your internet, dude. Um, Today I'm going to finish up what I started yesterday, giving myself more time. We didn't have many bugs, or any bugs, today to fix, so looks pretty good. Um, alright, let's get started with this. Since you're here early, you'll get some 3 stars. There you go. And almost there. There we go. There we go. Good job. All right. Let's see. So today it is about finishing up the engine that I had started yesterday. One of the viewers had brought up an interesting point, which is true. I was hoping to mitigate it. I'm sorry, mitigate. Uh, One of the issues that are tied to any kind of procedural generation. I think I'll be able to get past the overhead though, just because of how small the area that's being updated is at any given time. And this is a single player game. But if I want to, this is what I hate about programming and love about programming, right? It's that there's many ways to handle the exact same issue, and it's just a matter of picking which way fits what you're trying to design the best. And then you get lured into that temptation of, oh, but I could make this even more scalable or more broadly applicable. At a certain point, you just have to say, no, this is the application that I'm trying to get this for. And otherwise, you spend so much time on just, well, things. Let's get into it, though. Let's see. Okay. How's the audio, Moin? Is it alright? My voice is coming through fine, and is the music too loud, or is it everything okay? Fantastic. Alright. Alright, let's get to work. So, where we left off, we just wrote our 3 scripts, and we ended off at the world generator. The next step was going to be to make the delta. So this is what the data, on the data side, this is the magical stuff. This stuff can all be changing. In my mind, what I'm going to do is just having this running at all times effectively. So we can do all of this number crunching without having an impact on the game. It's super fast, it's all going to be lookups. Where we start to get into issues is with huge scales, if we're dealing with an infinite world effectively kind of thing. Now, we do a good job of dumping, but if we have a lot of the world being rendered at the same time, this is not the system for that. This system kind of assumes that you're going to have LOD and that there's a certain range of the world that you want to render in. So you can have infinite world with this, but it's going to assume that at a certain point, you want your world to lose some information because the player is just not there, right? Like we're just talking about terrain. We're not talking about anything else right now. Terrain and foliage and stuff like that. Okay, Um, I see. All right, so if we get to it, if we get out of this section of just data, we might be getting into the world visualizer today also. So that's the part that we're going to probably be doing a little bit of multi-threading with. I'm not sure if I'm going to be using Unity's burst compile or if we're just going to use an async yet. When we get there, we'll cross that bridge. Okay, so let's work on world delta. I'm going to create a new script. There we go. Hello, Relly. Now, there's only one legend around here, bro. That's you. You're good, brother. You make magic happens with your fingertips. I just make games. Or in this case, an engine. Okay, so we have the world generator here. So now we're going to be creating the world delta. We've been using the namespace delta voxel engine core. So we're going to keep that going forward. Let's go there. Okay, so there's a couple of things that we're going to want to have for this game that I just popped into my head. We can increase these as we go along, but for this, in my mind, we're just going to have something like an impact event or a dig event, right? So this is going to be something that alters the ground. So we can call it, I mean, probably this is a bad name, but do it over here. We might change it later. Right, so in here we're going to want to have the center of the impact that we're dealing with. So let's... So this is not, this is a vector2 int. So what this is targeting is not like a specific geometry, or sorry, a specific place in the world, position in the world. It's referencing a piece of data that this thing should count as its center. Then that thing is going to propagate to its neighbors what should happen. And so we just do a public float force and a subseed. let's keep things the same. That's what happens, right? You go one day and start messing up your own syntax. Then we do a public int for the subseed. Okay. So this will give us this subseed right here is what is part of the magic. This is going to start creating seeds for us that we'll be able to combine together to form basically a number, and that number we will be able to then normalize between the original state of whatever the object is. And so we'll be able to reverse time on the mesh later on to bring the mesh back to its original state or bring it back to this subseed state. Thus, we get like this whole animation interval that's going to be happening in between. That's the idea behind this. All right, so we're going to not serialize this. Let's call it radius. That's what it is. And then we can just do public impact. So this is the constructor for this. Um, sure, that's close enough. We're just going to use this, and we're just going to get the square root, so we don't actually need this. There we go. So we're just going to get the square root of the force. There we go. Okay. And that'll be the effective radius. All right. So that's our impact. So we send these events through to our, and this is what's going to compose our world delta. All right, let's get started with the delta now. So like I was saying, we could probably get away with making this inherit like a generic event and just having, like, that's what I'm thinking. I'm going to do this later, but for right now, we only have one, which is when we shoot the ground, it'll have an impact event and it'll just send us stuff. But there might be other reasons in like a full-on game that uses this for having one of these events. So let's just do a list of impact events. Public list fact. Yeah. Let's check chat. I will be back soon. All right. I'll see you when you get back, Moy. All right. So events. Of course, Unity wants to make sure that I'm using NUnit framework for some reason, because that's the default that it selects. Tab through. System. Collections. Eric. There we go. All right. So we're going to be using something that Unity has that is really useful for just patterns like the combinator, but we're not using a combinator here. So this is just going to be what's called a record. Effectively like a struct, but it's you know what? We can just make it an event. Not an event, a method. We don't need it to be fact event. Because I was thinking of making it like a kind of machine, but I guess not. And handle the process internally, but it's probably best to keep it at this level. We don't need to go deep. And then we just do a clear. Okay, so this is our little delta package. This is what's going around. We create these deltas using the events, and then our system at the bottom is going to handle the whole processing part of this. So let's now do that. Public class fact processor. So should we make this one serialized? No, we don't need to. We don't have anything that we want to do. So public loot, and we're going to have a shatter threshold for this. So the idea is when you hit someone into a wall, or hit them into the ground, or you shoot the ground, shoot the wall, there has to be a threshold before the ground will break. So that's all we're setting up here. The amount of force that's going to be needed to do that. We're going to just set that to 5F. And then we'll do a very familiar dictionary. Now we'll start doing in private, read only, dictionary. No. Nice try though. So Do we use vector to int this? Yes, we do. And we want to track the columns that we're dealing with. Yeah. Call this the world. I should probably wrap. I don't know. I think it's good enough where it is. So this is where we're going to make our segments. So let's start doing that. So public, or should I do private? Private, yeah, private, read only. We haven't made this class yet. We're about to make it. All right. Let's go down here. Just when we get to it, we'll get to it. All right. So now let's do public. Give ourselves a good API. Act processor. All right. So we need the dictionary. There we go. And now we can just do an application. So we take in impact events here. And then we just do e dot and do we do this? It's we care about the force first. And we need to know that the force is greater than a shadow threshold. And if it is, then we just call shatter on it. And pass in the same. There we go. Yeah. And then for that, so we're in this case, I'm going to try to have like the ground shake when not the camera shake, the actual mesh quiver. What else? Like I said, I promise nothing, but we're going to try. And let's change this to EVT. That's what it is. Hey, good morning, Nipple. Okay, so first we're going to knock this out similar to what we did yesterday. We create these methods and we're just going to fill them in. So the first one we're going to fill in is a slab, and this is going to be the, the physical slab that we're going to remove. So now we just need to figure out what slabs these are. So the very first thing we want to do is... first thing we want to do, keep these processors. Okay, fine. I wanted to try to figure out a way to like cache this, but it... yeah. Are you? There you go. Sealed the end. That looks right. That looks fine. Okay. Yeah, that's fine. Var. Yeah, so now we just need to get the coordinate. So we get the event center. Just need to convert that. Alright. Coord going to be the VT dot center. Yep, there it is. And we just need to offset this now by the chords that we just got. So that would just be plus. Yep, there we go. Pretty simple. Alright, next step is we need to get the distance and the power. So, same process. I should probably cache that. Yeah, we should cache that. So let's go var d is going to be equal to this. No, we can't. We need to, it's two separate. That formula, it would cost us more compute to do it, to put this into a function out, into a lambda. So just have to do it again. Just looking for little ways to save. Not really a big deal. So first we just do if not, we check the world. And we can just continue. That means that we don't actually have, this just means we don't actually have the tile or the slab that we're looking for in the world. It doesn't exist. Alright, fine. Bar this. Have to be. We're gonna have to do it again. Square root. And we can just get the dx. Same thing. Okay. And then float power. So this is just 1f minus distance. Alright, that should do the trick. Right, now if we actually have slabs, we need to iterate through them. Or if we have a matching slab, this is now we need to iterate through them and get rid of the nearest neighbors. So for int I is going to be equal to world. Oh. I'll see. Yep, that's actually right. Autocomplete actually did it right the first time. I bet. Usually it fails on those double. Next, where is it? There it is, double. And then we just do call or see that. I could have sworn we made a remove for these though. Oh, yep, there it is. Okay. So now we just tell the segment that it's dirty. So segment, and we pass in the, or actually we should do it, because this is not is dirty, we should mark it as dirty. And we want to mark the coordinate as dirty. There we go. So right now we haven't touched anything that can render yet. This is just saying, hey, mark the segment manager, mark when something is ready. When the segment manager is ready to do its own thing, it will tell the visualization, hey, I've updated. Let's visualize what I have dirty to make it clean. That's the idea behind it. All right, so this stuff can happen as many times as it wants to. Computers love crunching these types of numbers. Once we get here, that's where it starts to get a little heavy, so I'm debating how we're going to handle it. Segment manager is our little window that is going to abstract between this and the visualization of it. Okay, so let's now do with ripples. Ripples are much simpler. Public. We called it trigger ripple, right? Yeah, trigger ripple. All right. So this one's, we just need to contact our shader and set the global vector. We're going to call this ripple origin. Here. Alright, so now we're going to just pass in a new vector for how it should handle, or the position, how it should set the position for this. I mean, pretty obvious, right? New vector 4. Get the event center. And we're just going to pass in a 0 on the y because we don't care about y, and or rather, don't care about what it thinks is y. We go the here, and we pass in the force w. Nice. Okay. And finally, we just need to do the global float for this shader. So shader, and do ripple time. So now it's going to just do what it needs to do, and we can just, it should have its own. When we make this, it will have its own like time scale that it knows how to handle things by. So we're just going to pass it time.time. Okay, that should do it. We need to make our segment manager. Before we do that, let's handle the last part of this, the last linchpin of this whole process, which is the reconstructor. This is here, public class reconstructor. Let's take a small break to read chat. To read thing. Ah, nope. Okay, snap file. Was the last cool beans. And Twitch being Twitch. Okay, let's see. So for this, we're going to be using some statics. So let's just do it like that, because this is more like a helper. Yeah, static. Oh, need to pass back a world on this. And we're going to pass through our column. And we're just going to call this root drop. So we need to pass in a couple of things for this to work. The first one we just made, which is going to be our world generator. Well, made that before. Second one we need to pass in is the world shape that we care about. And the last we need to pass in is the world delta just made. Alright. Okay, so first we refresh the world. So if our world be equal to generator, right? Then we need to now update the segments or tell the segment manager that it's going to be dirty. So we can go var seg var equal to new segment, and the segment manager is going to take in the world. Our processor just made up there. We're just going to make a new impact processor, and we pass in the world segment. Alright, and then finally we will do a loop through for it to just apply any deltas that should exist. So for each we can just do processor. Right, and from there, we just return the world. Pretty straightforward. Let's do a brief sanity check to make sure that we didn't screw something up before we move on. This is pretty self-explanatory. We are just getting the position of the object in the world, the amount of force that the player or whatever the object was, ability did, and the subseed that's attached to this force. So this is just going to just be something that composes itself onto the seed for the delta here. This will effectively repaint, make the normal world change, the normal 2D mesh change, because we're not using cubes. It's actually just one 2D mesh that we're using all of this. What else? World delta. Clear. Alright, I think we're good. We just need to put in the segment manager and should be fine. Mark dirty is something that needs to be done as well. Alright. To help myself out a little bit, I'm going to just write the segment manager. But we're giving it its own class, or its own script. Yeah. There we go. Okay. Give my IDE time to do its thing. There we go. Awesome. Alright. So this one's a little bit different. We're going to have something called segments, right? We're going to basically be making these segments dirty. each segment now is what the world visualizer is going to read in order to figure out, hey, what should this part look like when things happen there. So effectively, this is just all read-only. So we can actually do that. So let's do that. Private read-only dictionary. Vector to column. Why didn't it pick up on vector 2? Oh, using. Oh, there we go. So this one is going to be the world. Be familiar. So here we're going to have our segment. Right? Just as a reminder of where they came from, this is it. Remember at the very beginning, we made our data structures. So we had our slabs, we have our columns, and we have our segments. So we made these. We have our little is dirty check here. All right, and then finally we have the private read-only transform. Actually, be clear about what this is. Okay, so now when we get when we construct this, we're going to just take in the world effectively. So dictionary. And this can be. Oh. We need to rebuild this. So let's whenever this is called, we do a rebuild. This is assuming like the game just started. What? Yeah, okay. kv.key and it's gonna be a bit weird. Yeah, we need to actually write segment origin because I'm gonna start getting confused. Yeah, we need to actually write this. So let's do this first. It's going to be something that we're going to need. Right, I'm going to take in the vector 2 and call it a Alright, so not ready yet to implement it proper, so we're just going to out That's what I mean. Like, I'm already messing up over here because I did not respect. So if the segment doesn't contain the key, we want to add the segment. Right, so we go segment, and it takes in the origin, so kv.key, as well as world. Oh, whoops. Forgot we get it from the key, so let's like origin is safer. Yep, there we go. That looks all right. Okay, good stuff. I skipped a little bit, but we're going to get to the segment origin in it. So now let's just get our mark dirty method done. Public mark. And we're just going to take in the coordinate, right? So okay, good stuff. Next. So let's take sanity break real quick. Bottle of water that I always forget to drink. Sorry if I missed the explanation, but what is the high-level feature you're working on as a whole? Good morning, Zach. Sure. So this is a Delta Voxel engine. So the idea behind it is we store the delta instead of storing the world. We split this into two sides. One side is data, and data can just run on the main thread. That is where all of that is happening. We visualize when the data requests for visualization, and we can then normalize the delta between the delta and the origin. So we can have like a kind of recording of all delta changes on terrain. This is handling terrain, so on terrain you'll be able to do something like I'll be able to slide a scroll bar or slide a bar and then be able to see like you've ever seen a game, there's a game out where you crash cars basically all the time, and you can see like how the car comes back to piece by piece during certain impacts and stuff. So that's what I'm working on. The uh, at the high level. So for my personal project, I'm planning on using this for the world generation part. It's always been a thing to have disruptible environments for me, so I wanted to try to put that in a different way, in a very cheap way if possible. So this is just one of many variations to me attacking that issue. But overall, this whole thing is a part of my, as far as YouTube goes, a part of my feature complete process, where I just, from scratch, I literally had nothing else. I mean, I have this, so this is my personal project that I call feature complete. I have a bunch of other projects that I do, but the idea of this project is I can go here, create a new environment, have absolutely nothing in it. There's no references to any of my other code or anything, and just make a feature to its complete state. The idea is then I could just take that feature later on for another project and just slap it in there. If all of a sudden I decide I need world generation and stuff like that, I will now have it with the Delta Voxel engine. So I can just grab that engine, slap it into the game, and suddenly we have procedural world generation and destructible environments and rivers and all types of good stuff. That's the idea behind it. I have another one, burn damage. If I wanted to, I can just grab the event system from that, slap it into anything, and now we can do various status effects, things like that. So that's what feature complete is for. I stream it so folks can be able to do the same thing. Like if they, the code here is, I try to keep it as modular as possible and scalable as possible for production based games. I don't promise anything, but I try to keep everything open with regards to what the code looks like, and I show where I make mistakes so others can learn from those mistakes as well. Okay. Alright, so we were here at Mark Dirty. And so now we just need a process for flushing out any dirties that we have. Public. Flush the dirty. So basically, for each, this one's super simple. For each, do we use for each? That work? Nope, doesn't. No, so we have to do it this way. I don't like this, but we'll do it this way. Kind of got locked in here. That sucked. Okay. So that's mostly done. So now we just need to make our rebuild segment method, and we should be good. You know what? Let's actually fill this in. Been dancing around it. So int, yeah. Name this one OX creator, and we'll math F for. So here we want to get the normalized value and then get the size. That will be our X coordinates. That's how we're going to find the X. So let's just pass this to a float first, and then we can do our coord X. Like that. For precision, segment size. And then we just multiply that by the segment size. Do the same thing over here. I think this is a... Thought that would be... But it makes some more sense to keep it consistent. Alright, and then from here we can just return this. Alright, so now let's do the rebuild. Public void build segment. Okay, so if the seg.root mesh root is equal to null, then we just return. Yeah, I wish it was that simple. Okay. So, let's see. So here, if we have nothing here, we want to create a root. That's basically what it is. So this is how we create a new game object with equals. Oh, whoops. Sure. And I guess we can call it like. Why is this? Change this. My bad. There we go. Okay. So now, if the root is, if we have one, seg dot so now we just need to clear any old children that might have been on the mesh, and then build and combine the meshes from all of the columns with this segment. So this is going to lead into some stuff. Like I said, I said that the segment manager was pretty dense yesterday. That's why I didn't want to try to finish on it yesterday. But we're here today. So let's do this. 4. I is going to be equal to the egg cut mesh root tile count. We subtract my 1 from that, and there we go. So then we just destroy each one. All right. These.
To give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty.
Interesting. So, all right, good. I might be putting stuff in the wrong place. Give me 1 second. Let me just walk myself through it a little bit.
In the sky, gazing far into the night, I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light shine through. If you believe it's true, baby, won't you let the light shine through for you.
That looks about right. Got it. Okay. Nice. Yeah. It's flowing. It looks good. So now let's get to the final part, which is our visualizer. Public static class. Mesh builder. Okay. First we want to try to track this. So private static read only. And call these the neighbors. Howdy, neighbor.
Eyes in the sky, gazing far into the night. I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light shine through. If you
There we go.
believe it's true, baby, won't you let the light.
All right, this is going to be a hefty one. Hold on to your hats. So we need to actually do this weird thing. Build a segment mesh. So we need to now read the data that's inside of this segment, as the world seed would tell us, and then produce a mesh that it can use. Okay. So it wants to be a mesh. Call it mesh. The terrain. So build segment. It takes in the segment and all right, looks like we're in the right direction. Static. Okay. All right. So it's been a while. How have you been? Are hold you. Then this one autocomplete. There you go. We're not going to call this 2. We're going to call this UV. It is. I am and the UV. And we just go here. Now we just do the WV equal to the same thing. There we go. Nice, now you're starting to get it. And love. Of this. Alright. So with the boilerplate out of the way. Still have... So, we're missing TN. Okay. What makes it... Free. Yeah. This is called a tuple. For some people don't know what these are, but this is just a tuple, so we're just returning these two types. And we store them as a tuple wherever is receiving them back. So, where's our create mesh? Oh, right here. Alright, and so you can just get access to the results of the tuple that way. You don't even have to name these. Like, if I just did something like this, I could do something like and we get that because we named it like that here. Right? Alright. Couples are pretty nice. Okay. Here we... I mean, if we mess something up here, it's going to become very obvious in a second. It's going to become absolutely obvious. So for LX, and we're going to be set 0. LX is less than segment LZ. All right. Get the coordinate now that we're dealing with. So get the segment origin. We need to offset it by the LZ. And now we can try to get it. So if not Haynes key coordinate, then we can just continue. Oh no, we should probably do it like this. Save ourselves the trouble. Try get value. Then we continue. Otherwise, we do stuff with instead of having to query it twice. So float. Want to get the WX out of this. Ward X. W out of it. Hasn't it picked up yet that I'm not using Y? That's crazy. Thought it would have picked that up already. Alright, so now that we have an internal, we can just do for each. Doesn't know what it's. There we go. Scared. See? Okay, so this is just visual style now. Are the tops of our object should look one way, right? It should have a I wanted it to have like kind of a 2D look to it, so a 2D isometric look to it. So that's kind of what I'm setting up here. With how the shader is going to handle this later. Going to be problematic. This.
Messing with my head again. You had your heart set on me, but these feels they come and go, and they come so easily. Tell me what it is about you that I can't forget, but you're breaking down my walls again just to set me free. Why do I, baby? Why do I love the way you always leave me? Why do I, baby? Why do I love the touch but never love the feeling? Why do I, baby? Why do I love the way you always leave me? Why do I, baby? Why do I love the touch but never love the feeling? Staying up when I go out, you gotta know I'm all yours. But when I say what's that about,
Okay, that'll make life a lot easier.
in your words,
All right, so
you have to seem so distant when I'm holding you.
like you see what I mean? Like I knew that I made a mistake somewhere here, and I caught it down here. So that's nice.
Why do I, baby? Why do I
Uh,
the way you always leave me?
see now.
Why do I, baby? Why do I love the touch but never love the feeling? Why do I, baby? Why do I love the way you always leave me? Why do I, baby? Why do I love the touch but never love the
All right, let's do an add quad on this.
do I, baby? Why do
Pass, and it's not doing anything yet. We're about to set it up, but we're going to pass in the hertz.
love the touch but never love the feeling?
And then the next thing that we want from this are we have to make a whole bunch of diff new vector. Pass in the wx is ab top y the wz. What did I miss? Oh, the array. Okay, gotcha. I haven't made the method for that yet. So, whatever. Vector3 dot up. We know that that's our direction. And I guess we're gonna call it our triplanar UV top. Go ahead and make that same way like we made the others. Just it's I mean, we could probably make the whole thing. It's actually much simpler than the add quad is going to be. Let's do that. Private static. Do array, and it's just the triplanar. B, right, and it takes in two floats. X, B. Okay, and so all we have to do is do a. Actually, we don't even need to do Charlie's on it. Super simple. All new array. It's going to have nice. It already knew like what I wanted. Almost had it. Close again. About the last one. Should be pretty obvious. Oh, okay. There you go. Okay, good stuff. Awesome. All right. So now that's the top face that we just built. So now we're going to build the bottom face of it. Oh, okay. So, the inverse. You know what? I could just do this. They're all. Usually I create bigger problems for myself when I do this, but it's fine. It's fine. And nothing here. There we go. Alright, and we just do vector 3 dot down. And we finish off with another triplanar call. This one will take the same thing, the X and the WZ. That should do it. Oof. And the last, well, second to last call we have to make is an emission call. Emissions, we have to do that. All right, let's just do it because we're trying to simulate 2D. So, well, give off the impression of 2D. We need to push things a little bit. So let's do, we haven't made this yet, emit side faces. This will take in the slab. Stop. There we go. And we can pass in the verts also. Nepal is back. Hey, what's good? Doctor's appointment was okay? In the snow? Didn't we just have a massive storm? I'm surprised, or was it like a at-home doctor's appointment kind of thing? And that's good to hear also. Doing all right. I want to get this done, and then I'm going to head out and start doing some shoveling. That's the idea. Okay, so now we're just going to do build mesh.
I've seen things that you wouldn't believe. I was lost until I found that I'm invincible. Nobody gonna bring me down.
Nice.
Here we go.
I'm invincible. Nobody gonna bring me down.
There we go. Done. Oh, I saw you were, oh, I forgot the name of the game now. Dragon something, right? I have Dragon's Dogma in my head. No, you were playing, Game of Thrones
King's Road. That's what it is. I'm like thinking House of the Dragon, I think. That's probably what it is. Alright. Yeah, yeah. So they didn't fix the sound effect then, or they think it. I guess they think it's a good sound effect. Maybe. Who knows? Let's work on our emit side faces. We're gonna knock out all of the hard ones at once. I think that's the best way mentally, because I think splitting them up is not working for me. Do private, static, emit, void.
Invincible.
Okay, that looks good. All right, let's get to work. A little tired today. We get past this. I think this is probably. We might be able to run visualization after this. No, we know we need one more script after this. I was hoping to get. This is the visualization part. It needs one more script to actually manage. Basically, on the. If you've noticed, we haven't done a single mono behavior yet. We need one. We need one in game to basically give a seed and then have it produce something. So right now we are just writing the back end, but I'm chugging through it. So maybe that same bottle of water I thought I was going to go drink, I did not drink. I read chat instead. So now I'm going to drink that bottle of water. There we go. We are now hydrated. Okay. So vector 2 int. Whoops. 2 int. Go. And we're going to take the direction. We're going to take the vector 3 normal. And vector 3. Oh, there we go. Okay. And we're creating a... So tuples are interesting, right? You don't need to have a tuple be only two things. You can pack them up with quite a few things, as you're seeing me do here. 3D. I'm gonna put these all into an array. All these faces. Okay, so we need it. Let me just make some notes for myself. We need a north, which is basically a plus B. We need a south, minus C. A west. Oh. Let's do.
You say I make you nervous, a tragedy, I'm a beautiful disaster, a reckoning, you wonder how I got
Okay,
this
so
way.
that's ultimately what we're aiming for.
You think I'm someone to be saved, someone to clean up and
Like
tame.
chat before I start doing this.
Never change, never change. You think I would look pretty on your arm once you cover up my
I've been
bruises
drinking.
and battle scars.
Potion sound effect is back. I've been drinking less and less, to be honest. Reason being, playing with a controller is working better for me. Yeah, I mean, certain games controller makes sense. Let's see. Jumping to the purple side. Ah, Twitch. Okay, gotcha. www. I'm tired today too. I hear you. I'm not exactly tired. It's just usually I do these types of things in smaller doses. Like I'll put in maybe 13 hours in it, but it's 13 hours like split with a couple of breaks in between. Knocking it all out in one go is kind of a bit. But we're trying, we're pushing. So I'm looking at it from the perspective of I want to try to get to. So my promise to myself today was to at least get this script done, the segment script done. But if I could push it to get to the actual visualization, I feel that would be a good reward for everyone. So like everyone could get to see, people who've been watching this can get to see, hey, this is what it looks like. So that's what I'm going for. And that's the script after this one. All right, but this one is kind of dense. Okay. Yeah.
What did I miss? It's vector 2. Oh, okay, there we go. Oh, Nepal, I forgot to... Here you go. Where is it? You missed it. There you go. Oh, shoot, you missed all of them. Alright, I'm going to send you one more. Ah, almost got you. Okay. There you go. Alright. Do 50-50. Make sure I just... Alright. Okay, so what are we looking at here? So this is just the general form that all of these kind of carry. It's like the general thing that they do. So the next one is going to be... Okay, that looks fine. The other one is going to even it out.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, hold tight.
Yeah.
Chemicals collide. Hold
Weird.
tight, hold tight, hold tight. Dripping
We'll see. When we do the meshes, if it looks all wonky, you know where the problem was.
because of you. Dripping lights paint the skies. Only you
Let's actually...
can make me
Ooh, shakalaka. Alright, we don't need one for the second. And I think that's basically it. Balance out second. Yep, there we go. Okay, next step. We have to actually put that stuff to work. So for each our dirt. Okay, so our neighbor. There we go. Oh, we have to... We haven't made it. We need to make this. Neighbor... We just need to pass in the world.
Seeing monsters at your window.
Have that.
No, you can't sleep. You pretend though. You don't have to play the hero.
Do it.
'Cause I got you.
Alright, and so now if it is exposed,
Scream until I last breath. Every heartbeat.
we add quad. Hurts. Did I miss something? Yeah, we did. Oh, we did it right. It's really here first. And the triplanar. Need the side.
When your nightmares turn to real life and the ground's filled up with landmines, we will face it standing side by side. You know I'll come running when you need. I'm coming. You know I'll come running. If you go to war, then I'm going with you. Pick up my sword, yeah, there's nothing I won't do. When you sound the alarm and the chaos is rising, leading the charge, yeah, I'm coming, I'm fighting. Swear on the breath that I breathe, I'll never retreat, yeah, I'll be your army.
I think that's it. Let's just make the neighbor cover slab face and we'll be in good standing with the piler. Almost good standing. Still have one down here. There we go. Oh, almost done. Return. Ooh. False. That should do the trick. All right. All right, we're finally in the home stretch of this thing. We only need to fill in what this does really, and what add quad is supposed to do. Now, add quad isn't too bad, so we can go ahead and do that. Because all we're doing is just adding ranges of stuff, updating these collections. So most of the entries are behind us. Still need to do build a mesh. Okay. Okay, let's do this. That could go here. Didn't I already? Where is it? It's not here. Oh. Yeah, I'm getting tired. Like, I just looked at it and then I'm like here typing it again. Alright, so it's basically just the int I is going to be equal to number of verts that we have. And once we do that, we just go verts dot add range. And we need to make a new array. And autocomplete already knew what I wanted to do. That's basically it. Same thing with the norms. New. So we need to track the normal. Four times. What else? Then we need to do the same thing with UVs. This one's a little bit easier. We just need to get the quad UV. One thing, because it's already in a good format for it. And then the last, not least, the redhead it is. Ew. One. We only need to go 3. Focus. Thank you. Okay, beautiful. And that's how we add a quad. Pretty straightforward. Okay. So this is very similar to the adding of the top. Let's just sides to it. So first we need to track out if it's a dominant side. No, the side face with the dominant horizontal axis. Just go bool is the X dominant. And we can figure that out. Absolute value of the normal X. Find out if that is greater. Absolute normal. Okay. So now we have to pack it together. Let's can we just copy paste Nope, we can't. Not gonna work. It's a different thing altogether. It's, if X is dominant, you only need to do it once and then copy it over. Oh. Do this. We got this. New vector 2.
There's a distance between us. It's getting hard to reach out. Haven't seen you in seasons, but all I hear is your voice. I know my limits. You can break me down, but I'll stay till the finish line. And I've been counting minutes for quite
No.
some time now, just to see you again. And I've been counting days to get away, to see you again, see you again. Been finding ways to get away, to see you again, see you again.
So this one's a little bit different. We just are going to use the X instead of the Z. Otherwise, everything else should be.
We got millions of reasons.
All right. And that's the triplanar side. What else are so we're missing the actual build mesh.
I know I'm not always strong. And I've
Build mesh.
been days to get away, to see you again, see you again. Been finding ways to get away, to see you again.
Oh, okay. All right. So if the vert is going to be equal to equal to 0, then we're just going to return an empty mesh. Otherwise, the var mesh equal to yes, we can. All right, so mesh, just need to get the various settings done for it now. Nice. There it is. Okay. Good. I want to set the vertices now. That in. We're gonna set the normals and the UVs. Yep, and we can just turn the mesh. What else are you crying about? What did I forget? Cannot implicitly. Let's check chat. Hey, Nepal. Can I do anything over here? I don't think I can. I think I have to actually be in chat for, or on the page for you to. Yeah. You can't make money unless you spend money, right? Gambling is the best way to spend money. This is not life advice. Just in-stream avatars. Only in-stream avatars. Let's see. So, build mesh. What did I do wrong? Where's it crying again? I forgot. It's crying. Oh, for build mesh. Saying what? It's saying that it doesn't match the formatting. Oh, gotcha. Because we're silly. We didn't make it right. It realize that's the setting. No, we could just call it twice. I thought I put like both in for, but it's fine. Build mesh. I thought I put them. I thought put it to take both the terrain and water at the same. I don't know why. I don't know why. It's easier to just do it this way too. So this class is done. Second manager is completed. The step after this is where we create the diorama manager now, and that handles the whole calling this stuff up from the inspector and making things look pretty. And then we have the two shaders that we have to put in. This is making calls to shaders and they don't exist yet. How long have we been at this? Is a good question. Oh, it's only been 2 hours and I'm already this beat up. Wow, that's crazy. Okay. I think we just need water, that's it. 2 hours should be nothing. Alright. Okay, let's go back to Unity real quick. Do we have any exceptions? So, we look like we're good. Okay. Okay. So the last, well, not the last, the next script, because we're still going to have to make like a player controller and stuff like that at the end.
But we now need to make the diorama manager. And this one's a mono behavior. Diorama manager. Grab our namespace. We can generally close all of these other ones now. We won't be going back to them. At least not in this stream. Okay. Oh. Welcome to Unity, our very first mono behavior script. Oh, actually, we did a scriptable object script also. Let's see. Alright, so here we can do public and we'll just set it like some number 42. Doesn't matter what it is. So public. Oh, let's go 32. Oh. Let's do it over here. Better biomes. So now we're going to get a public for objects.
I'm on my own, broken and alone. I feel the rain crashing down all around this empty town. Searching for the lost and found.
Directional modifiers. Fallback. As far back as yesterday when I made that. Public. Directional modifier. Call them dir mods. Nice. All right. Help myself out a bit. How do you do that again? Oh.
do that. Cool beans. Okay. Ah, interesting. There we go. There we go. Alright, I was trying to do something, but, Vector. I sworn it was like, what is it? Mad like this? Whatever. Actually, even better. Yeah, there we go. Oh, that works.
Fallen one too many times. Feeling like it never ends. Back again, square one. Tried to leave myself behind. Looking for a better place, not to stay alone. Gain our trust and you chose to break it. Ask for truth, but you only fake it. Thought you said what we had was sacred. It's all lies, all lies. I was broken and isolated, but inside held the fire waiting. Not a word that you say can save this, so don't try. 'Cause this time you crossed the line. Funny how the tables turned. Didn't think I'd go this far, but here we are. The
Okay, so what I'm gonna do
now you're just a lesson
is
slowly fading.
we're going to, we have a massive script ahead of us. Absolutely enormous. Which is going to be the world visualizing. So we have to get this world visualizer done before we do the diorama. I jumped ahead a little bit. Because we get, so what we're doing here is we get all of this stuff to happen, which is great, but
we also need to do a few more things to it. We have a mesh. Mesh is waiting to be used. Um, but we're stalling it a little bit, so that way we don't get stutters on the main thread when we're ready to apply impact. Um, apply the impact event changes, which is what the world visualizer is meant to do, and it's gonna be a chunky boy. Um, probably, probably this would be a good place to call it, because that's going to be a dense script, and no matter how much I want to push through it, I'm going to do this diorama script. I'm just going to comment out the visualizer references and just finish diorama, so at least this is out of the way. So next time that I come back to this, I can just jump straight into the world visualizer and just get that done. It'll be basically the world visualizer, to give you perspective, is about as it's going to include just about every single other thing that we have here in a deeper way to handle organizing the flow of the logic that's going through it. And so that's like easily maybe 500 lines that we're going to get into, maybe 400 around there. Yeah, 400, close to 500 lines. This one is going to probably be like 90, the diorama at most. Okay. Let's get the diorama done. So we're not going to use a little bit too late. Where we're going to want to get the component, which means that we probably want to, yeah, we'll do it in a second. We do it this way. I'm going to throw it on the visualizer. So the visualizer is going to require the diorama manager to be on the same. It's going to happen. So we're going to do it the other way around. Do a generate world. Then private void. Just every late update, it tries to flush anything that might be in it. Visualizer. I'm gonna have something to refresh to do. Alright, and then in this we just need to do the world generate script now. So wait. So first we have to get a generator. Right, we pass in the seed got from the inspector, the dir bio mods. Biomes, there we go. And the world radius. Right, we need a world shape also. World shape.
So this is going to be equal to um right. So if it's a hexagon, then we just need to do a pass it as world shape, and we can do new hexagon shape and pass in nothing actually. There we go. Oh, we don't need to cast it because already inherit. Okay, awesome. All right. So now world is going to be equal to the generator. Generate world, pass in the shape, the delta. Wait, ooh, oops. We need to store the delta somewhere, don't we? That's what we did. Oh, there it is. Called it wrong thing. Delta be equal to delta. Okay, good stuff. So then the segment manager. Next, the impact processor. So the segment manager should just be a new segment manager. And it's going to take in world. I guess the transform for this will be the root. And the impact processor. Also, new processor. And world also wants to take in the set. Right, and then from here, once we get this done, we can do underscore visualizer. Okay. Right, and this is basically the script. I mean, we can have a few more things that are important here, but this is basically it, because now we can just copy pasta this. For this, we just need to destroy everything. We can get rid of this. So now, instead of doing this, we just called World Reconstructor. Did I not make this? I could have sworn I made this. I think it's over here. I've called it. I remember distinctly making it, unless I'm like losing my mind. There it is. Oh, we just called it Reconstructor. Got it. And then we just update the segment and impact. Then we call visualizer on. That's basically the premise of this class. But I thought it was going to be the last class, but the rest of it is just going to be helpers to get like the current tile, and then get the tile underneath the current tile, or whatever is directly underneath the tile that we're looking at. So we don't have the data, we simulate the data only upon request. But the request is based on the seed. So each segment has its own seed again, and we just say, okay, if we're making a request, then we'll take the entire segment and then start to simulate the segment in data. We don't actually visualize anything. And that'll give us the information about what is going to be there once we go to visualize it. That's the entire idea. When the visualizer itself is going to be handling how we treat the is going to handle how we treat the game objects and how we effectively visualize the objects. Because we're not actively visualizing them when we do the instantiation. We're going to be playing tricks on it with this. Okay, I think that's where I'm going to call it for here. I'm pretty sure. I should definitely call it because I can feel it getting there. Thanks for joining. I will come back to this in a little bit, probably either tomorrow or maybe later in the week. Sure. But I just need to get the visualizer out of the way. That's the big camel hump right there. Once that's done, it's basically just a matter of pressing a button on the inspector to make it, or I'll actually just hitting play and yeah, making it visualize the world. Then from there, it's going to be making a player character and a camera to navigate, then making some abilities to shoot at the world terrain to carve it out and see how that works. All right, have a wonderful day, folks.